Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. And tonight I'll be going through Quiz 3 and Quiz 4 review. Let me remind you that Quiz 3 and 4 I'll be giving this Thursday, the 24th. At that point, I'll email you the passwords for Quiz 3 file and Quiz 4 file, which will be in two separate assignments in Blackboard. And you'll have until Friday, the end of the day, 11:59, to upload your answers for Quiz 3 and 4, separate files. And Quiz 3 has 4 pages, 8 problems. It's worth 50 points, and it covers Chapter 11, gases. Quiz 4 has also 4 pages, 13 problems, including 5 multiple choice questions. That also is worth 50 points, and it covers Chapter 12 and Part of 13, dealing with solutions. Now, let's go to Student View. If you go to Course Information, Lectures, and scroll down, you'll see I have a Quiz 3 review, also important information for Quiz 3, and Quiz 4 review, and important information for this. So what I'll be showing you today in this video is in the important lecture section of Blackboard that you can download. And let me open those files. Oh, by the way, I'm going to stick around after the review. If any students that are here tonight have questions, stick around. I'll stay later and answer questions. All right, first I just wanted to show you important information for Quiz 3. These are things you should know for Quiz 3. Until halfway through fall semester 2024, last year, the end of last year, I could put this at the end of a quiz. The chairperson at the chemistry department stopped that and said, all faculty, you can't do that anymore. So I can't. So this is all important information you should know for quiz 3. But let's go through the review. All right, and let me open up one more thing. Hold on, I'm having a technical difficulty. Let me. Here we found it. All right. Sorry about that. All right. When we talk about gases, there are different things you can measure in a gas. One is its volume in liters. The other is its temperature, which can be in Celsius or Kelvin. Remember, Kelvin equals degrees C plus 273, or pressure. And there's a mistake in here. That should be torr. In the important information, it's right here. And 1 millimeter mercury, Hg is mercury, equal 1 torr. So that also means 760 torr equals 760 millimeters of mercury equal 1 atmosphere. And these are all exact numbers. I just noticed a question someone just asked. And the question is, will the final exam include contents of exams and quizzes? Now, when we mean content, will it be the same type of problems? Yes. Will it be the identical problems? No. So if I'm going to show you things like I'm going to do for quiz 3, those can be on my test 2, which is my final, and the ACS final. Hopefully that answers your question. If it does, give me a thumbs up. If it doesn't, ask it again. All right. You're welcome. All right, now if we go to Chapter 11, Practice Problems, notice I have an example here. How many millimeters of mercury is 1245 torr? Well, here we have torr. We're trying to go to millimeters of mercury. Use unit analysis. You have a ratio. This goes on top, millimeters of mercury. Torr here, 1 millimeter of mercury equals 1 torr. So it's the same number, you just change units. But if we look at how many ATM atmospheres is 741 torr, whatever we have, 741 torr, we're trying to get the atmospheres. Here's what we have. We have a ratio to convert it. Units, atmospheres goes on top. Torr goes underneath. 1 atmosphere is 760 torr. And these are exact numbers. So 3 significant figures, my answer is 3 significant figures. Notice here in 5, I have atmospheres. I'm going to millimeters of mercury. Use 1 atmosphere, 760. These are exact numbers. This is 4 significant. My answer is 4 significant. Next, I talked about the ideal gas law. P1 times V1 equals P2 times V2. And P1 is the initial pressure of a gas. V1 is the initial volume of a gas. P2 is the final pressure of a gas. And V2 is the final volume. And generally, these problems, you'll be given P1, V1, and then on the second side, 2, you'll either given P2 or V2, and the one you're not given on the 2 side, you have to solve for. And if we look at number 6, and this is all from Chapter 11, Practice Problem Answers. If a balloon has 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.113 liters? Now, what are we trying to find? the final pressure, P2. The initial pressure, P1, is this, 658 torr. The initial volume is this, 1.1894 liters. And the final volume, what it's increased to, is 5.133 liters. So if you look at what we have to work with and what we're finding, trying to find pressure and volume, immediately I know P1 times V1 equals P2 times V2. Now, we're trying to find P2. We want it alone. We've got to get rid of V2. Anything divided by itself becomes the number one. So if I divide by V2, it cancels out. But whatever I do to one side, I have to do to the other, divide by V2. So we have P1 times V1 over V2 equal P2. I rewrote it, put my numbers in. Notice liters cancel out, and I'll put torr. This is three significant figures, 4, 4. So my answer is three significant figures. And that's how you do Boyle's law. Ooh. Keep a secret. I will not put on quiz 3 Charles' law. The math is too hard for 12, 11 students, so I won't put it on. No Charles' law in quiz 3. Now, next is the ideal gas law, my favorite mathematical formula in chemistry. That's PV equal nRT. Now, in the ideal gas law, P is in pressure, but the units are important. P has to be in atmospheres. V is the volume, but the volume has to be in liters. Ooh, N is the number of moles. C is the temperature in Kelvin, and R is the universal gas law constant. And for this class, we'll use 0.0821 atmospheres liter mole Kelvin. That's three significant figures. R is a calculated number, and this is three significant figures. And let's look at number 10. Let's have some fun. By the way, this is not realistic, but it's still fun because you can't burp that much CO2. Your lungs aren't big enough. But if you burped 86.75 grams of CO2 gas at 545 millimeters of mercury, that's the pressure, and 34.6 degrees C, then what is the volume of your burp? Oh, I forgot to put something on test number 10. If this were on a test, this would be 15 points. Yep, it's a lot of work, so that's why it's a lot of points. Again, if this were on a test, this would be 15 points. And so now we look at, what are we trying to find? Volume. We're given a weight, we're given a pressure, we're given a temperature. And the universal gas law constant is this, which I'll need later. Now, if you notice, nothing's changed. Everything stays the same. And that immediately tells you, you need to use PV equal nRT. Now, we want to solve for volume. We have to get rid of the pressure, who's P times V. Well, you divide by P. Anything divided by itself becomes the number one. But whatever you do to one side, you do to the other. So I divide by P. So P divided by P is 1 times V is V equal nRT over P. But these have to be in the right units. Pressure in atmospheres, so we have to convert 545 millimeters of mercury to atmospheres. You have a conversion, atmospheres go on top, millimeters of mercury go underneath. 1 atmosphere, 760, those are exact numbers. And I'm gonna round off at each step, so I round it off, and here's the pressure in atmospheres. The temperature has to be in Kelvin. Kelvin equals degrees C plus 273. Degrees C is 34.6 plus 273 is this. Remember, 273 is an exact number. Finally, N is the moles of CO2. Oh no, we're given the weight. So we have to convert the weight to moles. You have a conversion factor, whatever we're trying to get to goes on top, moles of CO2. Whatever we're trying to get rid of goes underneath, grams of CO2. And where do we get this relationship? 1 mole of a compound equals the molecular weight. The molecular weight of CO2 is 1 carbon, 2 oxygen. Each carbon to 3 significant figures is 12.0. 2 oxygen, 16.0 times 2, 32.0. So that's 44.0. 4 significant, exact number 3, 3 significant figures. Now, N is the moles that I get here. R is the universal gas law constant, which I will give you on quiz 3. Oops, I don't have it here, but on quiz 3, I'll give it to you. And then T is the temperature in Kelvin, and P is the pressure in atmospheres. Common mistake, students forget. N is not weight, it's moles. Pressure has to be in atmospheres, and you're never given that because I've never seen a gauge in atmospheres. It's always torr millimeters of mercury. And finally, temperature. I have never seen a temperature in Kelvin, a thermometer, but in Celsius, yes. And you put it in here, and 3, 3, 4, 3, 3 significant figures, and you get 69.4 liters CO2, and you get the same both ways. Now, the last one is Dalton's law of partial pressure. The total pressure of a mixture of gases equals the sum of the partial pressures. Again, the total sum of a gas, pressure of a mixture of gases equal the sum of the partial pressures. The partial pressure is the pressure of that gas in that mixture if it were alone. And that's how you get this. And I didn't think I gave any practice problems, but that's it. Now, something important you should know. When we talk about boiling, we're talking about gas. You've all seen water boil. Those are those little bubbles. And when something is boiling, the boiling point of a liquid is when the pressure, vapor pressure of the bubbles equals the atmospheric pressure, and that temperature is the boiling point. Now, you should know the higher the altitude you go on the Earth, our planet, the lower the atmospheric pressure. So as you go up higher, the pressure is lower, and that means the boiling point of a liquid is lower. In the video, I tell the story how I visited friends in Denver, the mile-high city. By the way, Chicago is at sea level, 0. Mile high is quite high. So the atmospheric pressure normally in Denver is much lower than atmospheric. And because of that, the boiling point of water in Denver is much lower than here in Chicago. If you go even higher, like this, where would be high? The top of the Himalayan mountains, that's high. That's the highest mountains on our planet. The boiling point is very low. Now, one other thing I want to remind you, and I tell the story how I actually use this, PV equal nRT, for your car tires. You have air, or some of them now have nitrogen. And in the winter, the temperature goes down. Now, in your car tires, PV equal nRT, V, N, and R are constant. So if this is true, PV equal nRT, the temperature goes down, then since the volume in your tire is constant, your pressure will go down. So in the dead of winter, your car tires look like they're going flat. No, it's just super cold outside. In the summer, especially back in the summer of 1995, that's a long time ago, we had a brutal summer. Many people died from the heat, and the temperature was way up. And if you drove on the expressways, you saw a lot of trucks and cars pull over with their tires blown out. Why? Well, again, PV equal nRT, volume, moles, and R in your tire are constant. Therefore, if the temperature goes up, the only thing on this side that can change is the pressure. And the pressure got big enough to blow out the tires. Bear with me while I open up a. All right, let's go through quiz 4 review. Before I start this, let me remind you, in the lecture section of Blackboard, cleverly named Important Information Quiz 4 are things you should know for quiz 4, which deals with solutions. These are things I used to be able to give to students. I can't anymore because of the directive from the chairperson. But I would have you make sure you know this on and other things I'm going to cover now. All right, when we talk about solutions, that's when you have one substance dissolved in another, but neither lose their chemical identity. If I were to take and put sugar in here or salt, mix it up, water is still going to be water, H2O, and the sodium chloride, the salt will still be NaCl. And I can take the water out and you'll have the salt left behind. All right, now let's go through some important things you should know. First of all, when we talk about a solution, we have two definitions you should know. The solvent is the component of a solution present in the greatest amount. The solvent is the component of a solution present in the greatest amount. And all other components are called solutes. Now, something that looks like a solution but is not is called a colloidal dispersion. And these are particles suspended in liquid. And how can you tell that? In the video, I got to show off my fancy Hank Wang flashlight. Hank Wang is a gentleman in China. He's probably the premier flashlight builder in the world. And I've got about 12 of his different ones. Dr. White is a flashlight collector. They're called flashaholics. I love flashlights. But anyways, a colloidal dispersion is not a solution. You can tell it because it scatters light. A solution, light will go straight through, but a colloidal dispersion will scatter that. Now, examples of solutions would be, like I just said, water and sugar, water and salt. Pop is a solution, gasoline is a solution. Colloidal dispersion, your blood, latex paint, ketchup, mayonnaise are all colloidal dispersions. Now, when we talk about solutions, there's a concept called like dissolves like. It's called the rule of thumb. It's on this thumb. No, it's on this thumb. Oh, it's bad joke, bad humor night. But anyways, it's 95% true, and that's why it's a rule of thumb, not a law. Law are 100% true. And that is like dissolves like. And like solutes are soluble in like solvents. And what that really means is polar solutes are soluble in polar solvents, and nonpolar solutes are soluble in nonpolar solvents. Now, water is the most polar substance in our world, and alcohols and salts are polar. Now, some things that are nonpolar are vegetable oil, gasoline, Vaseline, baby oil, and dirt and grease. They're all nonpolar, and you should know this. What does that mean? If I take water, like in vinegar, which is mainly water, and oil to make an oil vinaigrette dressing, it, after a minute or two, even though you're shaking it, after you put it down, it separates because the water is polar and the vegetable oil is nonpolar. Now, there's certain definitions you should know. Solubility of a solute. That's the maximum amount of solute that will dissolve in a given amount of solvent. Saturated solution. That's a solution that contains the maximum amount of solute that can be dissolved under conditions which the solution exists. A dilute solution, a solution that contains a small amount of solute relative to the amount that could dissolve. Bartenders don't like when you say, hey, you gave me a dilute drink. A concentrated solution contains a larger amount. It's not saturated, but you're getting close, of the solute that is relative to the amount that could dissolve. Now, this is important. Aqueous solution. That's a solution in which water is a solvent. I'll say it again. This is important. Aqueous solution. That's a solution in which water is the solvent, and it's abbreviated by bracket AQ, close bracket, aqueous. Now, when we talk about solutions, there are various ways of describing concentration. How much of a solute is in how much of a solvent? And the most important one for chemists is molarity. And molarity of a solution is a ratio giving the number of moles of solute per liter of solution. Molarity, which is designated by capital M, is moles of solute per liter of solution. And since 1 liter equals 1,000 milliliters, you can also write it as moles of solute per 1,000 milliliters. Now, if you look at the practice problems for chapter 12 and 13, alcohols or solutions, here's questions I've already gone through. Now, let's look at number 6. What does 1.34 capital M HCl means? As soon as you see a number, capital M, then a chemical formula, that means molarity. Moles per 1,000 milliliters or moles per liter. So that means 1.34 moles of HCl per 1,000 milliliters. Now, if we look at number 7, what does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what is the solvent of that solution? Well, capital M between a number and a formula is molarity. Moles per 1,000 milliliters. In this case, 4.56 times 10 to the third moles of NaCl per 1,000 milliliters. What's the solvent? The AQ tells you it is water. All right, now let's look at 2 important problems. Number 8, how many moles of NaCl are in 125 milliliters of a 3.54 capital M NaCl solution? We're trying to find moles of NaCl. We're given milliliters, and we're given this number 3.54 capital M NaCl. What does that mean? Ooh, capital M between a number and a formula, molarity. 3.54 moles of NaCl per 1,000 milliliters. So if we only have 125 milliliters to start with, we're trying to get the moles of NaCl. We have a ratio. It's time to use your good buddy, your good friend, unit analysis. Whatever we're trying to get to, the units go on top, moles of NaCl. Whatever we're trying to get rid of, the units go underneath, milliliters. Where do we get this number? From the molarity. 3.45 moles of NaCl per 1,000 milliliters. Now, the 1,000 is an exact number, but this is three significant figures. Our answer is 3 significant figures. Now, let's move on to a very important problem which chemists use to make stock solutions. And that is how many grams of NaCl are needed to make 345 milliliters of a 6.789 capital M NaCl solution. And here you need 2 steps. And if I stop for a second and go back to quiz review, Here are the two steps. In step one, for the two-step molarity, you convert milliliters to moles, like I just did. In step two, like you did for test one, convert moles to grams. And I give you a reminder, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of the compound is the sum of all atomic weights of that compound. Wow, long night tonight. All right, let's go back to that problem. So the first step, whatever you're given milliliters, you want to convert to moles. Well, we're given 345 milliliters. We want to go to moles of NaCl, because eventually we're going to convert that to grams. So use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. Where do we get those numbers? From the molarity. This means 6.789 capital M means 6.789 moles of NaCl per 1,000 milliliters, molarity. So I put those numbers in. This exact number, 3, 4. My answer should be 3 significant figures. Are we done? No. We want to get the grams of NaCl. So second step, moles to grams. Here we have 2.34 moles of NaCl, which we just calculated up here. We want to get the grams of NaCl. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of, the units go underneath. Where do we get a relationship between 1 mole of a compound and grams? We get it from 1 mole of a compound equals the molecular weight of compound in grams. The molecular weight of sodium chloride is the sum of all atomic weights, sodium and chlorine. And if we look it up, I closed my periodic table for some reason. Sodium is 23.0 to 3 significant figures. Atomic number, the number underneath the symbol on the chemical, the periodic table. Chlorine is 35.5. Add them up. 1 past the decimal, 1, so 1. So the molecular weight is 58.5. 3 exact number, 3 significant figures. You could also write that 1.37 times 10 squared. I'm just putting in scientific notation. Notice it says both ways. If you round off at the end or at each step, you get the same answer, and I calculate both ways. And that's it. I'll stick around if anybody has any questions. Oh, excuse me. Remember, quiz 3 and 4 this Thursday. Also, don't forget to hand in labs. Labs are important. The chemistry part has a rule, it's in my syllabus. If you don't get 65% of the points, possible points for the labs, you can't get higher than a D. And just hand in the labs. If you need help, see me. Come to my office hour or reach out to me and I'll help you. Maybe set up a Zoom meeting, private one. So remember this Thursday, quiz 3 and 4. I like the special effects 3 and 4. Am I good or what? Never mind. But it's time to say goodbye. I'll stick around afterward if anybody has any questions. So I'll say, gehen gesund which means go in health in Yiddish. And I'll say, bye now, bye. Stole that from Granny to Beverly Hillbillies. Bye.